Hello everyone. Today I am going to explain about graph traversals, specifically BFS and DFS. BFS means breadth first search and DFS means depth first search. Graphs are one of the most important data structure in computer science. They are used in social networks, Google Maps, recommendation systems, and many other applications. What is graph? Graph is a collection of vertices, edges. Vertices means nodes, edges means connections. As an example, Facebook. Peoples are nodes, friendships are edges. Another example, Google Maps. Cities are nodes, roads are edges. Another example, computer networks. Computers are nodes, cables are edges. Why were graphs introduced? Before graphs, we use trees to represent data. Trees works well for hierarchical structures like folders on a computer or organization chart. However, trees have some limitations. They must start from root node. They cannot have roots. There is only one path between two nodes. In real life, many systems do not follow these rules. For examples, on a Facebook, one person can be connected to many different people in different ways. In a road network, you can travel through multiple routes and even return to the same place. These relationships are more complex than tree can represent. Therefore, graphs were introduced because they can represent many connections, multiple paths, and cycles, making them suitable for real-world networks. Simply, trees are good for hierarchical data, but real-world networks are more complex. So, why graph traversal important? Graph traversal means visiting and exploring all nodes in a graph. Without graph traversal, we cannot search data, we cannot find routes or paths, we cannot understand relationship between nodes. Real-world applications like GPS navigation, graph traversal help find routes between locations. Social media platforms like Facebook, Instagram, and LinkedIn. Graph traversal help discover friends, mutual connections, and how users are connected. And also network analysis. Computer network use graph traversal to check connectivity and find best route for sending data. Graph traversal is important because it allows us to search, navigate, and analyze connected data. It's widely used in GPS systems, social media platforms, computer networks, and AI applications. Types of graph traversal. There are two methods in graph traversal. First one is BFS. BFS means breadth first search. Second one is DFS. DFS means depth first search. First of all, I am going to explain about BFS. BFS means breadth first search. Breadth first Search means visits nodes level by level. It first visits all neighboring nodes before moving deeper. The data structure used in BFS is queue, queue data structure. A queue works on FIFO principle. FIFO principle means first in, first out. As example, think BFS are visiting nodes level by level. Start at A. Visited A. After visiting A, visit neighboring of A, B and C. After visit B and C, visit neighboring of B and C, D, E, F. After visiting all the A, B, C, D, E, F, think of BFS as visiting not level by level. First of all, visit A. After visiting A, visiting neighboring of A, B, and C. After visiting B and C, visit neighboring of B and C, D, E, F. The final BFS order is A, B, C, D, E, F. BFS starts from A and visited not level by level. First A is visited, then B and C, and finally D, E, and F. Therefore, the BFS traversal order is A, B, C, D, E, F. So this is the BFS algorithm. Start at source code. Second, mark it visited. Third step, add it to queue. Fourth step, remove first node from a queue. Fifth one. Fifth step, visit all unvisited neighbors. Sixth step, repeat until queue is empty. BFS real-world applications. As example, Google Maps, finding shortest path. Another example, social media, finding mutual friends. Another example, network broadcasting, sending messages to all computers level by level. Depth first search. So what is depth first search? Depth first search explores one path completely before returning. It goes deep first. Data structure used in DFS is stack data structure. Stacks works on LIFO principle. LIFO principle means last in, first out. As example, first we can, as example, first visit A and then go to B and go to D. No more nodes from D. Backtrack to B, go to E. No more nodes from E. Backtrack to A, go to C, and go to F. DFS visits a node and then goes deep as possible along one branch. When it cannot go further, it backtracks and explores the next branch. In the example, the traversal order A, B, C, A, sorry. In the example, the traversal order A, B, D, E, C, and F. These are the uh, these are the basic steps of DFS algorithm. Start at source node, market visitor, visit one unvisited neighbor, continue deeper. If no neighbor exists, backtrack. Repeat until all nodes are visited. DFS real world applications. GPS navigation. Finding route from one location to another, exploring possible routes. Social media. Finding connection between peoples, friends of friends, and so on. Web crawling. Search engine visit web pages and follow links to discover new pages. File and folder search. Search through folders, subfolders, and files on computer. Network troubleshooting. Checking connection between computers and devices to find faults and broken links. There is a small comparison between BFS and DFS. Data structure used in BFS is queue. Data structure used in DFS is stack. The traversal style used in BFS is level by level. The traversal style used in DFS is deep first. The shortest path is yes in BFS. DFS not guaranteed. The shortest path. The shortest path not guaranteed. Memory location. Memory usage higher in BFS, lower in DFS. Graph traversal is essential for exploring and analyzing graph data structures. The two main traversal techniques are BFS and DFS. Breadth first search, which uses queue and visits nodes level by level. DFS, depth first search, which uses stack and explore deeper path first. Both algorithms are widely used in Google Maps, social networks, AI systems, network routing, and many other real-world applications. Thank you very much. See you in the next video.